Ever wonder how a massive machine like a dozer can move with such precision and power? The secret lies in a device called a torque converter. Welcome to the fascinating world of mechanical marvels. Today we're focusing on a component that's integral to the operation of heavy machinery, yet often overlooked: the torque converter. It's an ingenious device that sits between the engine and the transmission, and it's what allows machines like dozers to move smoothly and powerfully, regardless of the load they're carrying. Imagine a dozer at work. It's not just about brute force, it's about finesse, about controlled, precise movement. This is where the torque converter comes into play. It's a fluid coupling that transfers rotating power from the engine to a rotating driven load. In this case, the wheels of the dozer. It's what translates the raw power of the engine into smooth, controllable motion. Now let's break it down a bit. The torque converter has three main components: the impeller, which is connected to the engine, the turbine connected to the transmission, and the stator, which sits between them. The engine turns the impeller, which pushes oil against the turbine, causing it to spin. The stator, meanwhile, redirects the oil flow, maximizing efficiency and increasing torque output. So, in a nutshell, the torque converter is a fluid-driven clutch that allows the engine to keep running, even when the dozer is stationary. It's a marvel of engineering that allows for a smooth transition from a standstill to movement, and for the power of the engine to be fully utilized, no matter the load or the terrain. But that's not all. The torque converter also provides a certain degree of protection to the engine and transmission by smoothing out sudden shocks and loads, and by allowing the engine to idle without stalling when the dozer is stationary. So, next time you see a dozer in action, remember, it's the torque converter that's making all that power and precision possible. So, how exactly does a torque converter work? It's all about the magic of fluid dynamics. To understand this, we need to look at the three main components of a torque converter: the pump, the turbine, and the stator. Let's dive right in. The pump, which is also known as the impeller, is the first part of this trio. It's connected directly to the engine and spins at the same speed. As the engine revs up, the pump starts to spin, forcing transmission fluid outwards due to centrifugal force. Now let's move on to the turbine. The turbine sits inside the pump and is connected to the transmission. The transmission fluid forced out by the pump hits the turbine, causing it to spin. This is where the magic happens. The engine's rotational force, or torque, is transferred to the transmission through the fluid. But what about the stator? Well, the stator sits between the pump and the turbine, and it has a very important job. It redirects the flow of fluid returning from the turbine before it hits the pump again. This redirection of fluid flow increases the efficiency of the torque converter, allowing the engine to transmit more power to the wheels. So, what's the role of the transmission fluid in all this? The fluid is the medium that allows the torque converter to transfer power from the engine to the transmission. It's the fluid's movement that turns the turbine and, in turn, drives the wheels. It's worth noting that when the vehicle is at a complete stop, the fluid simply churns inside the converter, allowing the engine to run without stalling while the vehicle remains stationary. This is why you can remain in drive at a red light without stalling your engine. So, to sum it all up, a torque converter is a hydraulic coupling that uses fluid dynamics to transfer power from the engine to the wheels. It does this by using the pump to force transmission fluid onto the turbine, which then spins, driving the wheels. The stator then redirects the fluid back to the pump to start the process all over again. In essence, a torque converter is a clever piece of engineering that uses fluid dynamics to transmit power efficiently. Now that we understand how torque converters work, what benefits do they bring to a dozer? Well, the first benefit is smooth power transmission. The torque converter acts as a bridge between the engine and the transmission system, allowing power to flow seamlessly. The smooth power transmission means the dozer can glide over uneven terrain with ease, reducing the chances of getting stuck or straining the engine. Next, torque converters provide variable speed control. Unlike a direct drive system where speed is dictated by the engine's RPM, a torque converter allows for a wide range of speed control independent of the engine's speed. This means the operator can slow down or speed up the dozer without changing the engine's RPM, providing a level of control that's crucial in delicate operations. Then there's the ability to carry heavy loads without stalling the engine. Dozers are workhorses, often tasked with moving mountains of earth and debris. A torque converter ensures the dozer's engine doesn't stall under these hefty loads. It does this by multiplying torque when there's a significant difference between the input and output speed, giving the dozer the extra push it needs when the going gets tough. And it's not just about power and control. Torque converters also play a role in reducing mechanical wear and tear. By absorbing shocks and vibrations, they protect the drivetrain from damage, extending the life of your dozer and saving you from costly repairs. But perhaps the most significant benefit is the overall efficiency. By allowing for smooth power transmission, variable speed control, carrying heavy loads without stalling, and reducing mechanical wear and tear, a torque converter ensures a dozer can perform its tasks more efficiently and effectively. So, when you see a dozer in action, know that it's not just brute force at work. There's a sophisticated piece of machinery, the torque converter, working behind the scenes, making it all possible. As you can see, a torque converter is essential in enabling a dozer to perform its tasks efficiently and effectively. You might be wondering, are there alternatives to torque converters? Yes, there are, but they come with their own set of trade-offs. Let's dive into the world of torque converters and their main alternative, direct drive. Both have their own unique advantages and disadvantages, and understanding these can help you make an informed decision based on your specific needs. Direct drive systems, as the name suggests, provide a direct link between the engine and the wheels. This means that the power from the engine is transferred directly to the wheels without any conversion. Sounds efficient, right? Well, it is. Direct drive systems are known for their efficiency and simplicity. They allow for a smooth transfer of power, reducing the loss of energy in the process. But wait, if direct drive is so efficient, why would anyone choose a torque converter? Well, here's the kicker. Direct drive systems have a major drawback. They lack the flexibility to adapt to changing load conditions. This is where torque converters shine. Torque converters, on the other hand, excel in situations where the load conditions are variable and unpredictable. They provide the ability to multiply torque when the demand is high, giving heavy machinery like dozers the extra push they need to overcome obstacles and perform heavy-duty tasks. Moreover, torque converters eliminate the need for a clutch, reducing the risk of damage and wear and subsequently expensive repairs. They also provide smoother operation, especially during startup and at low speeds, making them ideal for tasks that require precision and control. In a nutshell, while direct drive systems offer efficiency and simplicity, they fall short in terms of versatility and adaptability to changing load conditions. Torque converters, while slightly less efficient, offer a better balance of power, adaptability, and control, making them the preferred choice for heavy machinery like dozers. While both systems have their merits, torque converters generally offer a better balance of power, efficiency, and versatility, especially for heavy-duty applications. As technology advances, what does the future hold for torque converters? This question is more relevant now than ever, as the world of heavy machinery continues to evolve. The future of torque converters is a topic filled with potential, as recent innovations are set to revolutionize the way we use and understand these vital components. One key innovation that's shaping the future of torque converters is the introduction of variable geometry. This cutting-edge feature allows the converter to adapt to different operating conditions, automatically adjusting its shape to optimize power transmission. The result? Enhanced performance and efficiency, particularly in dozers where varying ground conditions and workloads are the norm. Another exciting development is the lockup feature. By creating a direct link between the engine and the transmission, lockup converters eliminate the slippage that's inherent in traditional torque converters. This reduces fuel consumption and increases power output, making dozers more economical and environmentally friendly. But what about the impact of electric and hybrid technologies, you might ask? As the world moves towards greener solutions, the role of torque converters is also set to evolve. While electric and hybrid dozers are still in their infancy, they promise a future where torque converters can work in harmony with electric motors to deliver even greater efficiency and performance. In fact, the possibilities are endless. With advancements in material science, we may soon see torque converters made of lighter, stronger materials, further improving their efficiency and durability. And with the rise of digital technology, we could even see smart torque converters that can monitor their own performance and adjust their operation on the fly. While the technology may evolve, the fundamental role of the torque converter in powering heavy machinery is likely to remain unchanged. Despite all the changes on the horizon, the torque converter's basic function, to smoothly and efficiently transmit power from the engine to the drivetrain, will continue to be at the heart of heavy machinery operation. The future of torque converters, in a nutshell, is a future of continuous innovation and improvement.